Hi everyone, Senan this side, and in this video we're going to solve this Geeks for Geeks daily problem, which is largest pair sum. So before we get started, just go into the description below, find the solution PDF that I have provided with the GitHub link, and you would find all the explanation, solution, intuition, time and space complexity with the code itself, so that you don't have to watch this video again and again. So yeah, the question is asking find the largest pair sum in an array of distinct integers. This distinct is very important, right? So now what you do is you see these test cases, right? So what is this doing? Given this list, what you're doing is finding the largest and the second largest element, and you are returning this. In this, 20 and 30 are the second largest and largest respectively. So what you return is the number itself. If you look at the constraints, the array elements are positive, and the maximum value that could be attained at any element is 10 to the power 6, which means if you take the sum of two elements, it won't go beyond 2 into 10 to the power 6. So that can be stored into an integer. Next, what you see is the size of the array is greater than equal to 2. So in the worst case, not in the worst case, but in the best case, when you only have two elements, you have to return their sum. That's one more thing. Now, one straightforward way is you could just sort the elements and take the last two digits or last two elements. Sort the list and take the last two elements and you return their sum. Similarly in this case as well. But the time complexity in that case would be n log n, and the space complexity is big O of n, because let's say you're using merge sort takes big O of n space to sort the array. But yeah, anyways, this is quite a good approach. N log n is also a good approach, but can we go or can we improve this? And the answer to that is yes. What we are trying to do is by sorting is to somehow place the largest two elements at the end position of the array. But let's say we can find that in a single pass or in two passes, there is no need to sort in that case, and that is what we are going to do. So yeah, I take two variables, maxi and second maxi. So maxi would store the maximum element till now, and second maxi would store the second largest element till now, right? And since I have a size 2, so my till now is actually of size 2. Now if second maxi is actually greater than maxi, because there is no orders associated with array of 0 or array of 1, I just perform a swap so that the maximum element is actually in the maxi variable and the second maximum element is in the s maxi variable. Now for the remaining elements, what I do is I iterate through the list from I equal to 2 till the end, and what I do is if array of I is greater than maxi, that means I found an element or a number that is greater than my maximum element. So what would happen? My maximum would be updated to this number, so I update this maxi to this number. But before doing that, when I found a larger number than my maximum number, this maximum number now becomes the second largest number, right? So before reassigning this maxi, I assign that second maxi to maxi, and then I update this maxi. But let's say if I found an element array of I which is not greater than maxi, it's less than equal to maxi, but it's greater than second maxi. So I found a number that is greater than the second largest number, but it is less than the largest number. So this number is itself my second largest number. So second maxi is equal to array of I. Now the last case is that element is less than both maxi and second maxi, right? So that means I'm not even considering that number. So I don't do anything in the else part. So I go through this loop, and by the end I would have my maximum element stored in this maxi variable and the second largest element in this second maxi variable, and in the end I just return the largest pair, and that is the whole solution. Now if you observe, this is a constant time operation and this is a big O of n time complexity, right? This is big O of n time complexity and this is constant time operation. So this whole problem runs in a linear time complexity. And what is the space complexity? So space complexity is actually constant space because we are only using two variables. I'm not taking into account this array itself because this array, the space for this array is allocated by the caller of this function, right? So my question in itself does not use big O of n space separately, or it all just uses the array that is already provided. It does not use any extra space other than what is already provided as an input. So in that case, I would say that the space complexity is big O of 1 and the time complexity is. So yep, that is the whole video. Be sure to check the description to find the GitHub link for the PDF solution, and thanks for watching, and I'll see you in the next one.